Hi, questions in analysis in this textbook. Question 1. Let xn be a sequence and f be a function on the real field R such that fn equals xn for all positive integer n. Show that if those two limits exist, then those two limits are equal. Solution. Suppose that these two limits exist and L1, L2 are the values of these two limits. From this limit, for any positive number epsilon, there is a positive number m2 such that if x is greater than m2, the absolute value fx minus L2 is less than epsilon. So if n is greater than m2, the absolute value fn minus L2 is less than epsilon. This says the absolute value xn minus L2 is less than epsilon. This implies the limit xn equals L2 by the unit limit theorem for a sequence. These two limits are equal. This says this result. Question 2. Let A be a real number. By Taylor's formula, show that there is a real number C in the open interval 0x such that this equality holds. Solution. Consider this function. By Taylor's formula, there is a real number C in the open interval 0x such that we have this one. Then we compute those derivatives. Thus, we get this result. Question 3. Show that for x greater than 0, we have these inequalities. Solution. Consider this function. By Taylor's formula, fx is given by this one for some real number C1 in the open interval 0x. For x greater than 0, we have f prime and f double prime. So for x greater than 0, we have this one. This one gives this inequality for x greater than 0. This says we have this inequality for all x greater than 0. We also see that for x greater than 0, we have this one for some real number C2 in the open interval 0x. Then we compute these derivatives for x greater than 0. Then we have this one for x greater than 0. This gives this inequality for all x greater than 0. This says we have this inequality for all x greater than 0. We thus conclude this result. Thanks for watching. Bye.